This segment of the Water Distribution Operator Training Series will focus on water services and water meters. A water service is the pipeline carrying water from a utility's water main to the consumer's building or other point of use. Somewhere along this service line is a meter. In areas of mild temperatures without freezing, meters can be installed in garages, in meter boxes along the curb line or sidewalks, or on the side of buildings, if they are protected from tampering and vandalism. If a building has a basement, the meter can be placed in it, with the service line running under or through the foundation to keep it below the frost line. If placed inside a building, the meter is placed as close as possible to where the pipe enters the building to avoid the chance of a customer installing an illegal connection ahead of the meter. Interior meter installations also include a curb stop, located just off the customer's property so the water can be turned off for repairs or non-payment of bills. Many water meters are installed in meter boxes and meter pits. A meter box is used in warmer climates where it doesn't need to be as deep. A meter pit is used in northern climates where the service runs deep. Warmer air from inside the pit circulates around the meter to keep it from freezing in the winter. Meter pits require a tight-fitting lid. The advantages of meter boxes and pits are the ease of replacing or repairing the meters and the less likelihood that customers will tamper with the devices. The appropriate size of a service line depends on water pressure, the number of water-using appliances, and the distance between the main and the customer. The average single-family home requires a 3/4-inch service line. However, most utilities will install a 1-inch service line from the tap to the curb stop to provide greater flow and pressure at a minimum cost. Low water pressure or excessive distance between the main and customer necessitates a larger line to compensate for friction loss in the piping. Large buildings and customers require larger service lines depending on their patterns of use. Information on the water line sizing can be found in AWWA Manual M22, Sizing Water Service Lines and Meters. Service line pipe materials include copper, several types of plastic, galvanized iron, and lead. Service lines more than 2 inches in diameter are usually the same material as the water main. Lead and galvanized iron service lines were used in most systems originally, but many have been replaced by either copper or plastic lines. Copper and plastic lines are flexible, easy to install, corrosive resistant, and able to withstand high pressure. Both must meet National Sanitation Foundation standards to ensure that chemicals will not leach from the plastic into the customer's water supply. Every water service should have a shutoff valve called a curb stop or angle meter stop. In the past, an inverted plug-style valve was the most popular type of curb valve used. Some of these older curb valves can become difficult to turn over time and may eventually leak when operated. A curb stop with a ball valve is now often utilized because it turns more easily, even after years of non-use. If the water meter for a service is located in a pit or box, the curb stop is usually located just ahead of the meter and accessible through the box. There are various styles of lids for curb boxes, but most are operated by a special wrench to discourage unauthorized persons from removing the lid. The connection for a water service is made by tapping into the water main. If the water pressure is turned off, it's called a dry tap. If the pipe is pressurized, it's called a wet tap. For a dry tap, the water pressure is turned off and a threaded hole is drilled in the main to insert a fitting. Or a saddle with fittings can be placed over the pipe and is used to drill the hole. A wet tap is accomplished in a similar manner, except that the water main is still pressurized, which lessens the chance of contamination entering the main. Pipe manufacturers suggest that all taps larger than 1 inch, made on any type of pipe 6 inches or smaller, should be made through a saddle. Water service lines are connected to the water main through a special brass valve called a corporation stop. The valve provides a connection to the main and also allows the water to be turned off until the service connection is complete and ready for use. corporation stops that are used for direct insertion have a thread called an AWWA thread, with more of a taper than standard pipe thread so that it will quickly tighten as it is screwed into the pipe. It's generally recommended the tap on a main is at an angle of 45 degrees down from the top of the main. A tap at the top of the main is more likely to draw trapped air into the service line, and a tap near the bottom is more likely to draw in sediment from the main. The service pipe should be laid in an S-curve down from the tap so there's plenty of slack to allow for earth settlement and pipe expansion and contraction. Service pipes must be installed completely below the frost line, since they are particularly prone to freezing at night when water is not moving. Water service maintenance and repair is usually necessary due to either a leak or a frozen line. Freezing service lines are most likely to occur under roadways or driveways where the insulating snow cover has been cleared away. There are several methods used to thaw a frozen service line. A copper, lead, and galvanized line can be thawed by running an electrical current through it. This procedure can be dangerous and should only be conducted by experienced operators. Hot water and forced steam thawing are becoming more common because they are safer and can also be used on plastic service lines. After a frozen service pipe has been thawed, the only way to prevent it from freezing again is to open a faucet to allow a small continuous flow until the ground has thawed and the line can be relocated below the frost line. The most common location of leaks on old services is at the connection to the curb stop due to the twisting of the valve or movement of the curb box in the ground. Special fittings can be used to repair lead and galvanized iron pipe, but once the pipe has been disturbed, there's a good chance it will leak again. It may make more sense to replace the entire service with new material. Most water utilities meter water to their customers. A few utilities with abundant water supplies still charge a flat rate, and although there is a savings in meter installations and reading, customers on a flat rate tend to waste water. The most common meters used for measuring relatively low flow rates are called positive displacement meters because they accurately measure all water that passes through them by a disc or rotating piston. A register on the meter reads in gallons, cubic feet, or cubic meters. Positive displacement meters are not intended to operate at a full flow for extended periods of time. Continuous operation of this meter will eventually wear it out. Ideally, a meter should be sized so the maximum flow rate will be 1/2 of its maximum operating capacity. Meters are connected with special couplings designed to provide a seat against a gasket so meters can easily be replaced. To prevent customer tampering with meters, a seal of some sort should be installed. For large water services, a current or velocity meter is most often used. The principal types are turbine, multi-jet, and propeller meters. These meters measure the flow of water as it travels through their rotors or propellers. There are a number of other types of meters used for large water flows, such as proportional, venturi, orifice, magnetic, ultrasonic, insertion, single jet, and compound meters. All meters that operate on the principle of determining water flow velocity are designed with the assumption of laminar flow through the meter. Any disturbance, such as pipe bends or valves that might create eddy currents in the water, either before or after the meter, can cause inaccuracies. Meter manufacturers will recommend the minimum straight pipe distance that should be maintained on either side of the meter. Early design meters were circular or round reading registers which were difficult to read. They have largely been replaced by straight reading registers similar to a car odometer. Traditional meter reading involved a person visiting each meter site and reading and recording each meter. Water and snow in the meter pits, as well as access to homes and buildings, have made this a challenging task. One alternative is a doorknob card that asks the customer to read the meter and return it in the mail. If a reading is missed, the utility may opt to send an estimated bill. Another option is a remote reading device. A remote register is placed outside of the building or basement where it can be accessed by the meter reader. The next advancement in remote meter reading was electronic meter reading. The meter reader carries an electronic unit called an interrogator with a probe that only needs to be held in the proximity of the register to obtain a reading. Other electronic units plug directly into a receptacle for the reading. The most recent advancement used by utilities is automatic meter reading. Each meter has a small transmitter that sends the reading electronically on command. The readings can be sent via phone, cable television, or electric power lines. Or a reading can be sent by radio signal when a meter reader walks down the street or drives in a truck with a handheld computer to interrogate the meters by their code numbers. A caution about remote or automatic reading systems. Utilities need to occasionally inspect the meter itself for signs of damage, tampering, and to make sure it matches the remote readings. Manufacturers test new meters before they are shipped so they will be ready for installation. However, some state public utility regulatory commissions require a certain percentage of new meters be tested for accuracy. The limits of acceptable accuracy are dictated by AWWA standards. AWWA also designates recommended testing intervals for meters once in service, depending on their size. Since water meters gradually decrease in efficiency and under-register as water flows through them, 5/8-inch size meters should be tested at least every 10 years. Larger meters should be tested more often since there is a greater loss of revenue if they aren't registering correctly. Meters are tested on a bench at high, medium, and low flow rates to ensure they are in conformance with AWWA standards. Meters in need of repair must be disassembled, cleaned, and worn parts replaced as necessary. It's important that all testing and replacement of meters be carefully documented so that customer billing records remain accurate. Water meters can be considered the cash registers of a public water system. Meters should be properly chosen, installed, maintained, and read to obtain the necessary revenue for water system operations.